Alright, so we're looking at Chapter 4, Section 4, Solving Quadratic Equations. So we have 3 class activities for this section. So real quick, the other types of equations that we have been solving are linear equations. Linear equations. Alright, and an example of what a linear equation looks like is maybe y equals 2x plus 3. That's an example of a linear equation. So we have the y variable and the x variable, and then numbers. A quadratic equation looks a little different, and because it's a different type of equation, we have different methods for solving it. And we're going to take a look at those methods in this video. So let's take a look at what a quadratic equation looks like. So I'm going to make one that looks very similar to the linear equation, but there's going to be one difference, and I want to see if you can spot that one difference. Take a look at these two equations. One is linear, this one, and the other one is quadratic, this one. And there are very different methods used to solve these equations. What is the difference between these two equations? Well, the only difference is this little thing here, the exponent on the x. Okay, that's what makes it different between a linear equation. Linear equations, the exponents are a 1. For quadratic equation, we bring in that squared exponent, and we're just going to focus on the ones where x has the square. Okay, or one of the variables has the square. This is a quadratic equation because we've got that square going on. Okay, so at the moment we're putting aside linear equations and we're going to focus on how to solve quadratic equations. And there are 2 methods that we're going to look at. There's the square root property. And there is the quadratic formula. That might sound familiar. Okay, so 2 different properties we're going to look at for solving quadratic equations. Alright, so let's take a look at the first class activity that we have. So, class activity number 1, square root property. Let me bring this down. There we go. Square root property. So here's my first question for you. I think there are 5 questions on this class activity. Number 1. So what number, or numbers, times itself gives us the number 4? Pause the video and think about that. What 2 numbers times itself gives us 4? Or what number, times itself gives us 4. So what I'm looking for is something that when I multiply it to itself, I get 4. And it has to be the same number in both of these parentheses. Well, one example would be 2 times 2, right? 2 times 2 is 4. But there's another number. And that number would be negative 2 times negative 2 equals 4. Okay? All right, so if I was to say, now the reason this is important is because if I was to say I have a number times itself that equals 4, so a number times itself equals 4, how could I simplify x times x? That would be x squared, right? So x squared equals 4. If I was trying to solve this equation, the answer for this is not just going to be 2, right? It's also going to be negative 2. So the answer for x squared equals 4 is actually going to be x equals plus or minus 2. We have 2 answers, right? The positive 2, let me do the plus sign, and we have the negative 2. There are 2 answers for a number times itself equal to 4. Okay, and that's going to be the important thing for this class activity. That little plus or minus symbol is very important because we have 2 possible answers. Okay, let's take a look at actually using the square root property. So this just gives us an idea of what the square root property is talking about. So we're asked to solve this. R squared equals 9. Okay, so what number times itself gives us 9? Well, we could go through this whole process, but instead we're going to use the square root property, which means I can take the square root of this side. Okay, so the square root of a number squared is just going to be itself. So it'll cancel out that, we'll just say it cancels out the 2. It's not really what happens. Okay, and then what you do to one side, you have to do to the other, right? It's an equation. So we got to take the square root of this side. But remember, we get the positive and the negative version of the answer. So we need to write plus or minus on that side, which means that r equals plus or minus the square root of 9. Well, what's the square root of 9? What number times itself gives us 9? Well, 3. So r equals plus or minus 3. And there we go, our 2 answers. And that was the square root property. We take the square root of both sides and we get plus or minus 9. All right, so note the square root property works on quadratics of the form y equals ax squared, where a is a number. Okay, for example, it works on something of the form, let's see, y equals 3x squared. It could work on something like this. So when we just have the x squared and we don't have anything like an x to the 1 power, we just have the x squared power. Okay, let me just erase that example so I can have more room for our class activities. All right, number 3. 2n squared equals 20. Solve for n. Well, I might be tempted to immediately go ahead and square root both sides. But if I did that, let me do that with my erasing pen. If I took the square root of both sides, I'd have to figure out what the square root of 2 is, which I don't really know a nice number for that. That's going to be a decimal. So I don't want to take the square root quite yet. What I want to do is I want to get the item being squared, so this one, I want to get that by itself, the n squared. To do that, let's divide both sides by 2. Okay, because I want to get that squared value by itself. So now when I do that, look, the squared value is by itself. That's what I want. 20 divided by 2 is 10. Okay, so now it looks just like what we had up here. So let's go ahead and take the square root of both sides. And when I do that, I need to remember the very important plus or minus, because there are 2 answers. So n equals plus or minus the square root of 10. And the square root of 10, I don't have a nice number on that, so you can just leave it as the square root of 10, unless asked otherwise. So if they ask for a decimal approximation or something, plug that into your calculator and you can find that. All right, 2 more to go. Number 4. 15 plus c squared equals 96. Okay, so same thing. Remember, my goal is to get the c squared by itself. And at the moment, it is not by itself. So goal, get the variable squared by itself. Kind of similar to how we solve linear equations. All right, so let's minus that 15 from both sides. And what do we have left? C squared equals, that's going to be, what is that, 81? And now, look, we have our c squared by itself. We can go ahead and use our square root property. And when we do that, we're going to remember to put what? Yep, the plus or minus. So c equals, because that cancels, plus or minus the square root of 81. And what is the square root of 81? That's 9. Plus or minus 9. All right, so our last problem, number 5. Now this one looks a little different, but the square root property will still work on it. Okay? So here we go. T minus 9 squared equals 81. This looks different than the other ones because we have something going on. We have parentheses going on. But that's not really a problem because, see our variable, t? It is inside the object being squared. I don't see a t anywhere else. There's no t being added to the 81. the variable's only appearing inside the parentheses. That's good. When I see that, when I see the variable inside the parentheses being squared, I can use the square root property. I'll go ahead and use that. I'll square root this whole parentheses. I can do that because it's in parentheses. Okay? And then square root this side, and what do I need to put? The plus or minus. Yes, very good. That cancels, and I have t minus 9 is left, equals plus or minus the square root of 81. Let's see, can I simplify this? Yeah, so t minus 9 equals plus or minus the square root of 81 is 9. All right, so I want to solve for t, which means I need to get that negative 9 to the other side. So we're going to add 9 to both sides. Now when we do this, normally we'll add the 9, or the number, to the front, in front of that plus or minus. Okay, so we have plus 9. So then we get t equals 9 plus or minus 9. Now that's kind of weird. Okay, we have 9 plus or minus 9. How would I write that out? Well, I'm going to squeeze it in on the side. I have two options. I have 9 plus 9 and 9 minus 9. Two answers. Remember, we got two answers going on. So what's 9 plus 9? 18. That's my one answer. But remember, we're looking for 2. What is 9 minus 9? Well, that's 0. And there I have my second answer for t. So t equals 18 and t equals 0. And that is the square root property for solving quadratics. Okay, the square root property works basically when we only have the x squared variable going on, or the one variable squared. So the question is, what do we do when we have the variable to the first power? Well, that is class activity number 2. So what do we do? Here we go, quadratic formula. All right, quadratic formula is a good thing to have memorized, and I will post the quadratic formula song video to La Lima that you guys can take a look at and try to remember the quadratic formula. All right, so since I don't have that with us now, here is the formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And you might be wondering, where are all these b's and a's and c's coming from? Well, these are coming from the sort of generic way we look at a formula. Sorry, a quadratic equation. So if we have a quadratic equation, y equals, let me write this out, quadratic equation, y equals ax squared plus bx plus c. Okay, so this is what we would generically look at. Here's the a, it's a number, b, which is also a number, and c. So let me give you an example quadratic, and we can get a better idea of what those numbers would be. So y equals, how about 2x squared plus 3x plus 5. Okay, so if I was to pull off what the a, b, and c values are for this equation in order to plug it into the quadratic formula, my a value would be, well, the number by the x squared. Where's the x squared? Right there. What's the number? 2. My b value is the number by the x. Where's the x? Right there. There's b, 3. And my c value is the guy that does not have the variable next to it. Who doesn't have the variable? 5. So that's how I would I would pull out these values, and I could then plug them into the quadratic formula and solve. Okay, so the main reason we can't use the square root property on this equation is because of this guy. See the x to the first power? If we didn't have the x to the first power, then we could use the square root property. But because we do, we're going to go ahead and use the quadratic formula for now. All right, so let's take a look at a problem. We'll do one on this class activity, and then we're going to end up doing one on the other class activity. So here we go, using the quadratic formula. We have x squared minus x minus 6 equals 0. Got to solve this. Okay. Well, I see that x to the 1 power, which means, oh, shucks, I can't use the square root property, though I like to use it, so I'm going to need to use the quadratic formula. Okay. So to use the quadratic formula, I need to find out what my a, b, and c values are. Okay, go ahead, pause the video, see if you can find the a, b, and c values. All right, the a value is by the x squared. So what's the number in front of x squared? Remember, it's that invisible 1. The b value is the number in front of the x. So what's the number in front of x? It's the -1. That's another sneaky one. And then our c value is the one that does not have a variable, which is -6. All right, so now I have found my ABCs. And let's write out our formula, which we have now memorized. X equals -b. So what's my b value? -1. So let's plug that in. -1. Plus or minus, that's how the formula is going, the square root of b squared. So we found out what b was. It's -1. Minus 4 times ac. So what is our a value? A is 1. And what's our c value? -6. All over 2 times a. And my a value was 1. Okay, so not too bad. As long as you have the formula memorized, it's pretty straightforward in how to plug them in. You just got to remember all those parentheses. Because we have so many negatives floating around, the parentheses are going to be really helpful so you don't accidentally miss a sign. All right, so this is going to equal opposite of -1, +1. Plus or minus the square root of 1 squared is 1. And then we have 4 times 1. It's going to be 4. So -4 times -6. All over 2 times 1 is 2. Okay, let's see. We're going to go ahead and simplify more inside the square root. 1 plus or minus the square root of 1. -4 times -6 is going to be positive 24. All over 2. Okay, simplifying further. A lot of the times you end up simplifying inside the square root quite a bit. 1 plus or minus 1 plus 24 is 25. All over 2. Okay, still simplifying. Here we go. What is the square root of 25? That's 5, right? So this is 1 plus or minus 5 over 2. And now we've hit that point where we can't do anything else. We need to figure out how to do that addition. So when we hit this point, this is where we split it up in those 2 separate options I showed you before. So we have 1 plus 5 all over 2 and 1 minus 5 over 2, our 2 options. That's going to be 6 over 2, which simplifies to 3. This is going to be 1 minus 5, -4 over 2, which will simplify to -2. And there we go, my 2 answers for my quadratic. X equals -2 and x equals 3. Okay, and that's an example of how you'd use the quadratic formula for solving a quadratic when you don't have just the x squared. So when you have the full set of x squared and x, we're going to be using the quadratic formula. All right, and our last class activity for this video, an application. So class activity number 3. So apps of quadratics. Okay, so let's go ahead. A triangle has sides of the following lengths. Okay, so here we go. We got a triangle. I'm going to put that square in. What does the square mean for a triangle? That means it's a right triangle. That's very important to know for this problem. We want to know that it's a right triangle, and I'll tell you why in a sec. Okay, here's the length of the sides, 3, 4, and the one side we do not know, t. Okay, so we want to know what is the length of the hypotenuse. The hypotenuse? What is the hypotenuse? Well, the hypotenuse is the longest side, okay? So which side is the longest side? Well, the t. So we want to know what our variable is. It makes sense. That's the only number we don't know. So the question is, how can we find this out? So for a word problem, remember, we're going to need an equation. So do we know an equation that has to do with right triangles? Is there a famous equation that has to do with right triangles? Maybe you're kind of remembering it starts with a P. The Pythagorean? Yeah, the Pythagorean theorem. So, Pythagorean theorem. We have that if you have a right triangle with sides A, B, and C, we know this. A squared plus the B squared value should equal the C squared value. This is all dependent on the fact that our triangle is a right triangle. So, is our triangle a right triangle? Why, yes it is. There we go. It's a right triangle. That little square tells me it's a right triangle. So we're going to use this to create an equation. All right, so using a squared plus b squared equals c squared. So it actually doesn't matter which side is a or b, since it's just addition. So I'm just going to take my two sides, or my two legs, 3 and 4, and square them each. So 3 squared plus 4 squared. The Pythagorean tells me that this should equal my hypotenuse squared, so t squared. All right, and there we go. I have an equation. So now I can solve for my variable t. How handy. Okay, so what is 3 squared? 3 squared is 9, plus 4 squared, 16, equals, and t squared, we don't know what that is yet, t squared. So does this look like we're going to need to use the quadratic equation or the square root property? Take a second and think. Quadratic or square root? We have two options. Okay, this is going to be easiest using the square root property. Why did I say that? Because notice, we only have the t squared. We don't have the t appearing somewhere. If we had, for example, 16t, then I would be using the quadratic formula. But because we just have t squared, we can use the square root property, which tends to be much simpler. All right, so let's do that. 9 plus 16 is 25 equals t squared. Okay, and I'm going to go ahead and just flip this around so it looks more familiar to us. T squared equals 25. I haven't done anything to change the problem. 25 equals t squared. That's the same exact thing as t squared equals 25. All right, so now this is perfectly set up for the square root property. I have my t squared by itself. So let's square root both sides to get rid of that square. And then when I do that, what do I need? Plus or minus. So t equals plus or minus the square root of 5, the square root of 25. And simplifying that, t equals plus or minus 5. All right, but we have to pause and ask ourselves a question here. I have two answers, 5 and negative 5. Do they both make sense for this word problem? Does it make sense to have a positive length? Yeah, that makes sense. So positive 5 would work. What about negative 5? Does it make sense to have a side of negative 5 units? No, that doesn't make sense. So if I have t equals 5 and t equals negative 5, this answer for my word problem does not make sense. It's extraneous. It does not make sense for this word problem, so it's not useful. Okay, so we actually only have one answer. So our answer is the hypotenuse is 5, and we don't have any units given, so I'll just say 5 units long, period. Okay. And there we go. That was an app of quadratics. If you come across an application in your homework and you want help with it, just go ahead and email me and I'll do my best to try and get a video back to you on how to solve that problem.